So you got to know binary. It's going to be real important in this class and really in a lot of future in computer. Not knowing binary in computer science is like not being able to read music when you're a musician. You'll just be constantly humiliated by not knowing it until you're compelled to learn it. So nibbles are where you can start. And let's see if I can, all right, I'm not going to jump down by a page, that's life. All right, so in base 10 is ordinary numbers. We have 10 digits. If you write 147, you know this is 100, 4 tens, and 7. So the rightmost digit is ones. The next one is the base, which is 10 to the 1. Next one is the base squared, 10 squared, and so on. So in base 10, you know this is the ones place, the tens place, and the hundreds place. But in base 2, you only have 0 and 1. So your base 2, so 1, 1 means 1, 2 plus 1. That's 3. And the 1 is 2 to the 0, and the 2 is 2 to the 1. So it follows the same pattern. And so if you have a 3-digit number in base 2, you have 1s, 2s, and 4s. So this number is 5. You have 4 plus 1 and no 2s. And so this number is 7. That's 1 plus 2 plus 4. So with 3 bits, you can only count up to 7. Right? But if you have 4 bits, you have half of a byte, and they call that a nibble. And so you have only 4 bits. This is the 1s, 2s, 4s, and 8s. So this number is 9. That's 1 8 plus 1. And so with 4 bits, nibbles, you can count up to 15. The largest number is 1 plus 2 plus 4 plus 8, which is 15. And one thing that's kind of handy to remember is that 10, 10 is 10. And all right, so that's nibbles. Let's see if you can do some of these. Here's the project. You get some points. You get enough of these right in a row, you get a flag. So what's that? 1, 1. Anybody can call it out or put it in the Twitch chat. It's not 2. Nope, because the right digit is number 1s, and the next one is number 2s. So 1, 0 would be 2. Any other guesses? 12, you say? 4. It's not 4, because this digit is number 1s, this digit is number 2s, and that digit is number 4s. So 4 would be 1, 0, 0.
So it starts like from the left side also?
Always from the right. The rightmost digit is the number 1s, the next one is number 2s, this is number 4s, and that's the number of 8s. Yeah, you get 3, exactly, because you have a 1 and you have a 2 and nothing else. So that's 3.
So decimal always comes from the right side, yeah?
Always from the right, yep, exactly. So how about this one?
It's 3.
It's not 3.
4.
It's not 4. You follow the procedure. You start from the right. This is the number of 1s. Yeah, go ahead. It's 1, right? This is the number of 1s. This is the number of 2s, 4s, and 8s. So it's 1, 1, and nothing else. This is 1. All right. How about this one? You start from the right. This is the number of 1s, 2s, 4s, and 8s. Go ahead. Yep. He's got it. 5. You have 1 and you have 4. That's 5. You just count the ones where there's a 1. The zeros don't count. So that's 5. All right, how about this one?
11.
What's that?
11.
What's that?
11.
It's not 11.
13.
It's 13. Because you have 1, you don't have 2s, plus 4 plus 8. So this is 12, and 1 more is 13. Okay? I'm going to get this one wrong so I don't reveal the flag, but we'll go back. Correct answer to that one is 13. And let me just try a few more. How about that? He's got it. That's 0. Nothing. You have no, that 0 is just range 0. How about this one? Have you got it? Got a guess? Okay, what happens? You start at the right. This digit is number 1s. This is the number of 2s and the number of 4s and the number of 8s. So what do you get if you add up all the ones that have a 1?
So that
You have a 1, and you have a 2, and you have a 4. So what do you get when you add them together?
9.
No, 1 plus 2 plus 4. What's 1 plus 2? 1 plus 2 is 3. What happens when you add 4? You get 7. This is 7. Okay? You look unhappy. Let's try another one. How about this one? How many 1s have you got? It's not 2. How many 1s have you got?
1.
Nope, 0. There's 0 1s. That's what this number means. How many 2s have you got? That's what you do. You count across the digits. The one on the right is the number of 1s, so there are none of them. The next one is the number of 2s, so there's 1, 2. The next one is the number of 4s. So there's a 2 and a 4, and nothing else.
6.
Yeah, that's it. You just add them up, and all right, so that's 6. All right, how about this one?
Uh, 1.
It's not 1 because the number of 1s is here, and there are no 1s. So what goes here? What is the significance of that 1 there? If this is 1s, what's that? 2s. So you have 1, 2. This is 2. Okay? Do one more of these. How about that one? How many 1s have you got?
2.
Okay, how many 2s?
2.
Nope, 0. No 2s. Yep, and how many 4s?
So it's 0 and it's become a 4.
This is counting the number of 4s. Yeah, this is the 4s place. So you have a 1, but you don't have a 2 or a 4, but you do have an 8. That's what's going on here. So what have you got? You have
You have a 1 in the 1's place, a 0 in the 2 place, a 0 in the 4th place, and then you have 1 in the 8th place.
right. So you have an 8 and you have a 1. So it's 9. Okay, but you don't look happy about it. So you just count from the right. How many 1s have you got? Okay, how many 2s?
9.
No, we got a 1 there. That means you have a 2. This digit counts the number of 2s. This digit counts the number of 4s. How many of them have you got?
0,
And how many 8s have you got?
1,
Right, so you have a 1, a 2, and an 8. So what's that?
11.
11. That's all there is to it. All right. Well, I think I'll stop. That's enough of that.
It's
Lem-
tricky.
What's that?
It's tricky.
You get used to it. You realize it's nothing more than what you've been doing all your life with base 10. It may seem strange, but if you look at this, you've been doing it all your life, 147. You've been knowing that this is the number of 1s, this is the number of 10s, and that's the number of 100s. It's the same system. It just seems unfamiliar. But it's the same logic. The digits on the left count for more. Anyway, all right, good. Now I see somebody got 7 there. All right, so that's enough of that. I'm going to stop this recording.